I already got the first one drawn up here, but we'll go through a couple where we have to do the drawing. But this is find the distance from the origin to a point on a graph, but you don't actually know what the point is. That's kind of the deal. How do you do that? How do you write it as a single expression of x? But we're finding we got some point xy, and it's a point on the graph of x squared minus 1. That's already been graphed for you. This is y equals x squared minus 1. And here's the point xy. And part A is to express the distance d from P to the origin as a function of x. And when you talk about expressing something as a function of x, that means that the only variable it has is what? What's the only variable it's allowed to have if it's a function of x? Yellowish. Okay, this piece right here means the only variable is x. That's it. There are no other unknowns in this thing. Just what? That's the only unknown. Now, hopefully you saw a distance, and hopefully something popped in your head, because that's how you're going to have to start it out. What popped in your head when you saw distance? Distance formula? You know, maybe you thought, okay, d equals the root of x minus x squared plus y minus y squared. Now, that equation actually has two unknowns. Actually, this in sense four. You got to know two different x values and two different y values, right? That's not a function of x, is it? No. So the deal is, first off, just write a general equation describing what's being asked. Secondly, look at the graph. It says something. What's the graph tell you? Well, it gives you a point. One of those x's and one of those y's can be replaced with what? We're finding a distance from a point xy to the origin, right? So one of those x's and one of those y's can be replaced with what? Zeros. That's a good place to start. You know, I can think like this. I can clean that up quite a bit. Isn't x minus 0 x? And y minus 0 y? You should be doing stuff like that. You shouldn't be leaving it like x minus 0. So we went from 4 unknowns to 2, but we're still not a function of x. Right now we're a function of x and y. So now we got to get down to just your x's. Look at the graph. It's sitting there staring at you. You know what y is, don't you? Taylor said y is x squared minus 20. So where I see a y in my equation, I get to replace it with x squared minus 20. Now it's a function of x. And I'm going to say it is. Distance composed of x is the root of x squared plus x squared minus 1. What has to be done with that x squared minus 1? All squared? Because y was squared. How many unknowns does that have? 1. That is a function of x. Is that so bad? It all depends if you know distance formula, to be honest with you. Honest to God, how many of y'all know distance formula? That's about 70%. 80%. That's what it starts with. We're not gonna. I'm not gonna clean that thing up anymore because it's just you're not gonna gain anything and you might screw it up. You know, if somebody in here thinks x squared minus 1 all squared is x to the 4th minus probably 1. It's not, is it? How would you square x squared minus 1? You FOIL it out. All right, let's do part B. What is the distance if x is 0? I haven't had much sleep, so my memory is just shot. So long-term memory is there, but anything that I say or do within 5 seconds is gone. So I literally need to copy that question down because I will not remember it. Part B is what is the distance of x equals 0? So I'm going to grab my little equation here. Lauren, how do you do part B? You plug in a 0. You plug in a 0. That's not hard.
I'll use function notation. D sub 0, decomposed of 0, 0 squared plus a 0 squared minus 1, all squared. So if you do all the math inside that radical, what's actually in there? A 1, right? What's your answer then? 1. Now, here's why that's true. If x is 0 and you're on the graph of the parabola, right there. Because on the graph of the parabola, that's where x is what? 1. Wait, that's where x is 0. Hold on, I'm putting it in the wrong spot. It's not there. The x is 0, you're right there on the parabola, aren't you? The distance, though, happens to be what? To the origin. 1. Why is there no plus or minus? It's distance. Plus, there's only a plus or minus symbol when you're actually solving for an unknown. If you have like x squared equals 4, the square tells you there's how many answers. 2. That's when plus or minus is. But distance is a positive constant.
All right, so B is easy. What's up with C? What is the distance if x is 1? Well, what are we going to plug into that thing?
I'll plug in a 1. We're not going to get a very pretty answer. I don't think we will. Well, really? No, we get this. Yeah, because I actually plotted that point earlier. That's a stupid thing to say. What's that thing end up being? 1 again. Because I plotted that earlier in the wrong place. It's right there. What's D asking for? Another distance? Probably what x is 2? Oh, root 2 over 2. So 45, 45 minutes better. That's kind of ugly to plug in on paper, isn't it?
It's not going to be a bad problem, no. It's really not. If you were to square a root of 2 over 2, what would you have? If you were to square a root of 2 over 2, what would you have? You wouldn't have 1. You'd have a root of 2 times root of 2, which is 2, over a 2 times a 2, which is 4.
So when you square the root of 2 over 2, you get halves, don't you? The final answer might be 1. I don't know. I feel like it's probably 2. But I don't know. That's probably is 1.
On the square root and the square cancels that out, so the size.
Ah, that old one. That one.
You always
always have this problem. Things have to work for numbers to make sense. What's 3 squared? What's 4 squared? What's their sum? 9 plus 16? 25. What's square root of 25? There's a plus symbol in between there, guys. The plus and minus symbols do not, they throw away the ability to cancel out within radical. Because you know full well this is the root of 25, which is fine. And you always run into kids, and almost everybody does it some point in life. They see this and they think, oh, that's 3 plus 4. No, it's not, is it? If there's a plus or minus symbol in between some squares and taking square roots, you can't throw away the square. They don't cancel each other out. It just doesn't work with numbers. That might be what you're thinking. A lot of kids think like that. Well, anyways, that's going to be a half. So you're a half. You're a half. So inside the radical, we have 1/2 plus 1/2 minus 1 all squared. So half minus 1's a negative half, isn't it? What's a negative half squared? What's a negative half squared? Quarter. Negative. You have a half plus a quarter. Come on, kids. 1/2 times 1/2. 1 times 1. 2 times 2. Who taught you 5th grade math? Nobody taught you 5th grade math, apparently. What's in that radical? 3/4. Can you take the root of 3? Can you take the root of 4? Yes. So the root of 3/4 is the root of 3/2. When I add those two fractions together, I'll have the root of 3/4. I cannot take the root of 3, but I can take the root of 4. Your calculator can't give you pretty answers like that. Sorry. That's all on you. If you want the pretty answers, you gotta do the work. You gotta know how to add fractions. What's the last part? To graph this thing? Use a graphing utility to graph the function. Around 2 decimal places, find the values of x at which d has a local minimum. So that gives the point on the graph where y equals, where that gives you the point closest to the origin on the graph. So that ought to be easy enough. What do we spend on this slide? 15 minutes? I gotta quit asking questions from kids. So you guys have not used the minimum function on the calculator since Algebra 2. I don't think you have. I'm actually going to switch over to an older calculator that requires the use of parentheses instead of this newer one. Some of you guys are going to have older calculators. I'll pull up the new one too so you can see it. But I'm at y equals square root. The older calculator opens up a master set of parentheses. So x to the second. Then I have plus, don't I? Right? Plus x squared minus 1. That guy is squared. Now, parentheses really aren't that bad if you just kind of count them. I have 1, 2 opening. How many should there be closing? 2. That's what it looks like on an older calculator. Of course, if you have a new one, you can more or less just type it in. This one does not open a set of parentheses. You just keep it inside the radical until you're done.
So the newer ones are kind of nicer in that it's harder to screw things up. Anyways, I want to use the new one since it's up here. If I do a zoom 6, that's how you're supposed to zoom. Now, the problem said for all values where x is greater than or equal to 0, right? Isn't that what it said? So to find a local minimum where x is greater than or equal to 0, I am going to adjust my window. I'm going to make the x min 0 so that I only see the stuff to the right. And we're supposed to find a local minimum. That graph really doesn't tell me a whole lot. It looks like there's kind of a constant going on there. But to find a local minimum, you do a second trace what? Minimum. And you gotta ask for a left bound and a right bound. My x value started off at 5. Where'd y'all start off at? Yeah. Pay attention to what it says your x value is, because you're going to have to hold that back button for a second to see that cursor. But I don't know exactly what's going on in here. It's so small and hard for me to see. But there is probably a minimum somewhere between, I don't know, 0 and maybe when this thing starts going up. Wouldn't you think? So I went left. We actually took x all the way back to 0. I pressed enter. Now I'm going to the right where it's going up and pressing enter. And now I'm going in for a guess. There's a minimum, 0.70710535. Y is 0.8660254. 707 is a familiar number to me. I've been doing trig for 24 years. It's root of 2 over 2. There's your lowest x value. That 0.866 thing. I think you saw a y value, 0.866 something. Oh, sorry, that's not root of 3 over 3. It's root of 3 over 2. It's the point we just found. That was the actual absolute closest that graph ever gets to the origin. Hey, we did example 1. All right. On to example 2. Oh, that's still just continuing. All right, area of a rectangle. A rectangle has one corner on the graph of 25 minus x squared. And by the way, we're still doing the easy stuff here. Graphs are given to us. Another at the origin, a third on the positive y-axis, and the fourth on the positive x-axis. Part A is express the area of the rectangle as a function of x, which means that the only variable you have is what? X. Now to start off, you start off with how you found the area of a rectangle when you were in 6th grade. How did you find the area of a rectangle in 6th grade? Okay, silence again. Length times width, isn't it? But that's not an expression of x. Never has been, never will be. Now, this width right here is just some x value. You okay with that? That width is just an x value. The length of the rectangle, wouldn't that be some y value because it goes up? So there it is, rectangle is some y value times some x, or some x times y, however you want to write it, nobody cares. Right now it's area as a function of x and y, and goal as a function of x. Look at the graph. Just look at the graph. It's staring at you in the face. How do you make that thing a singular function of x? Look at it! Jaden, JC, want to tell me anything? Asia?
There's got to be some joke on there. Right there. Oh, it's not on your paper? It's up here. What are you going to do with that 25 minus x squared? Put it into what? Is it now an expression of x? Yeah, why? Because x is the only unknown.
B is kind of an interesting problem. Well, it's something a lot of kids will struggle with. Part B is about the domain of the area. Domain is values of x that make sense in a problem like this. Values of x that make sense. When it comes to area, can area be negative? No. Area cannot be negative, which means it should not be less than 0. That's kind of how you figure out the domain of this function. To find the domain of this function, all you do is you set it equal to 0. Because that's where your problems are going to arise if you were to come less than 0. That's all we have to do. So set equation equal to 0. So I'm going to say 0 equals 25 minus an x to the second times an x. Anybody know the two x values for that? Actually, there's 3, but only 2 of them make sense.
You really need me to go up there and slap the board. What do you do with each factor? What's it say x is? 0. What's the middle thing going to tell you? If 25 minus x squared is 0. Plus or minus 5. Now, would x being negative, if you look at your graph, make a lick of sense? No. It makes absolutely no sense. That's junk. It's garbage. It's extraneous. But if you just look at your graph, it makes sense that x is actually trapped between 0 and what? I already deleted my graph. Graph. What does x really mean to be trapped between 0 and what? Huh? 3? Let me undo the graph here. I think you can actually see it through. Five. Oh yeah, that's right. You guys don't have it, do you? I keep thinking 5. Stops at 5. That's what your answer choices are telling you. That's why we do this. So if you're using settler notation, all values of x such that x is stuck between 0 and 5. 0 less or equal to x, less or equal to 5. Using an interval notation, bracket 0, comma, 5, bracket. That's your domain.
Let's see here. Part C is to graph the area function. So I'm going to do that in TI-84. Our area function was x times 25 minus x squared. I'll zoom 6 it. I probably won't see anything. I see some stuff. Now it's asking for what value of x is area largest. Now, could x be negative? No, so I don't care about anything on the left of the origin. But if you see what I see, it looks like there might be a maximum somewhere up there. So what are we going to just look up? Y max. I'm just going to guess 100. 100 probably doesn't do it though. Well, it did with ease. Second trace maximum, you'll have your answer. Get a left and a right boundary. So left, press center. Right, press center. Enter for a guess. There's your maximum, about 2.89 or so. That gives you a maximum area of a little over 48 units. Now we're only going to do one more problem. I just need to decide which one. Oh, actually, there is only one more problem in there. That's the same thing. So here's one without a drawing, and that happens in your homework. They just give you a verbal description, and you're expected to draw, because if you're not drawing this stuff, you're really probably not going to figure it out. But a right triangle has one vertex on the graph of y equals x cubed minus 1. What's x cubed minus 1 look like? Looks like this. What it looks like. Starts low, ends high. You just take the mom and shift her down what? On you. Now, that would be the new one's origin, up 1 over 1, down 1, left 1, and then you just need some curvature. That was the transformation section in your book, kids. That's y equals x cubed minus 1. Notice I even wrote the equation on the graph because I'm going to look at the graph at some point in my life to figure out what y is. All right, so the triangle has one vertex on the graph, another at the origin. I'm going to start with that vertex at the origin. There's a solid out on the origin. A third on the positive y-axis, so that would be up here somewhere. And that means that the third vertex, the first one I actually talked about, is somewhere here. Now, I know a little bit about this. I know that this thing right here has to be 0, 0, because it's where? Origin. I only know that this is the positive y-axis, which means I actually know what x is. What's x here? 0. And this is some y. You okay with that? It's just a y value. I don't know what it is. Now, if this is a right angle, there has been no vertical change as I go to y equals x cubed minus 1. So y is still y. I've gone over some x units. There's my 3 coordinates. What's the goal here? Express the area of this triangle as a function of x. Thankfully, everybody in this room took formula coders last year. We had a triangle. Do you still know how to evaluate a triangle? Yay, nay? That's space times height. The formula's not going anywhere. We're not going to wake up one day and be like, we were wrong. We're at base times height. All right. I would call this guy my height. Now you don't have numbers really per se, but you go up. You don't really say how many units. You go up what kind of units. Maybe. Maybe y units. This is y units. It's y.
I would think this guy right here would be my base. How can you describe him in terms of units? X. Yeah, you're running to the right. X. 1/2 yx. Not an area of x function. You have this graph of it because you drew it. What can we do with 1? And now it is a function of x. I wouldn't worry about the distributive property. I wouldn't worry about the half. I would be done with that. Because you might screw it up. You're probably already going to screw some stuff up. So just stop. You have your homework. Your homework might be harder than this. It usually is, isn't it? Yeah, that's the way it goes.
That's the way it was when I was a kid. That's the way I teach. And God help me if I'm still teaching when I have your kids. It'll be the same then too. But homework is supposed to make you think a little bit. Can't be just like what you did in class. It has to be a little harder. It certainly doesn't need to be easier.